In this video, we will go over a particular homework problem in homework 3.5, and specifically question 13, where students are given a fraction of trigonometric functions of angles on the plane, and they are asked to make angles simple, acute, and positive. This assumes that theta is an acute and positive angle. Then simplify the fraction, so cross off common factors, and then use fundamental identities to fully simplify to a single ratio if necessary. Now, before you start this homework problem, you want to watch the video in section 3.5, video example number 3, find trigonometric functions from reference and coreference angles. And the particular part of the video that is very important is that you need to be able to identify in which quadrant your angle lies, and if the angle theta is a reference angle or a coreference angle. And the quadrant of your original angle in the problem will determine the sign of the trigonometric function you are looking for, and the angle theta being reference or coreference will determine whether you are going to use the same function or the cofunction of theta. If theta is an acute angle, then all its trigonometric functions are positive. So make sure you watch that video first and then watch this video that will walk you through the problem. So the most important thing here, we will do 3 steps. Step number 1 is to identify what angles we have. We have angle 90 plus theta, angle theta, negative 360 plus theta, negative 180 plus theta, negative 360 plus theta, negative 270 plus theta, minus theta, 360 degrees minus theta, negative 270 minus theta. That will be our step number 1. For each one of those angles, we will find the quadrant. So that will be step number 1. Based on that, we will identify the sign of the function. And after that, we will identify whether we must use the same function if we have a reference angle or a coreference angle to use the cofunction of theta. So the quadrant of the angle, not theta, but phi, the angle given in the parentheses, the sign of the trigonometric function we are trying to find, and whether we will use the same trigonometric function or the cofunction of theta. And that will depend on whether theta is a reference or a coreference angle. An angle is a reference angle if the point of reference is the horizontal axis. And in terms of rotation, horizontal axis is 0 degrees, 180 degrees, that's at pi, 360 degrees, that's back at 0, and negative 360, negative 180. If a coreference angle will be a reference in terms of the vertical axis, and rotations on the vertical axis will be 90 degrees, negative 90, 270, negative 270. So I'm starting with the first one. The sign of 90 plus theta. So my first task is to identify where is 90 plus theta. Assuming theta is an acute angle, 90 plus theta will be in quadrant 2. So that's in quadrant 2. The sign in quadrant 2 is positive. So I know that the sign of the trigonometric function I'm looking for is plus. Obviously, when you write that in your answer, you don't need the plus sign. The plus is just for me to remember. And 90 plus theta implies that theta is the coreference angle. So after the 90 degrees, I measure theta. Coreference angle means that I will use cofunctions, and the cofunction of sine is the cosine. So the sine of 90 plus theta will be the positive cosine of theta. That's my first trigonometric function. The next trigonometric function is tangent of theta. Theta is already acute. The reference is 0. I'm just going to leave it as tangent of theta. I'm not going to do any work for that. It's ready for me. The next is the sine of negative 360 plus theta. So I need to find out where that angle is. So I'm going to start here. That's 0 degrees. I'm going to go negative 360, which is over here. And then I'm going to go plus theta. So plus theta will take me to quadrant 1. The reference of theta is at negative 360. Negative 360 is on the horizontal axis, and this is a reference angle. Now, in quadrant 1, the sign of the angle is positive. So I'm going to use a positive function. And because this is a reference angle in terms of 360 degrees, then I don't use cofunctions, I use the regular functions. So the sine of negative 360 plus theta will be positive sine of theta. And again, I don't need the plus signs, I just write them for my own reference. The next angle is negative 180 plus theta. So for negative 180, let me grab a black pen. All right, I'm going to start at 0. I'm going to go negative 180, and then I'm going to go plus theta. And this is negative 180 plus theta. This is in quadrant 3. The sign in quadrant 3 is negative, so this will be minus. The reference is at 180 degrees, which is the x-axis. Therefore, theta is the reference angle. If it is the reference angle, then they have the same functions. So my angle negative 180 plus theta and the angle theta have the same sign, except for the sign of the sine function. So it is negative sine of theta. That corresponds to the function sine of negative 180 plus theta. This is with my numerator. I'm done. I'm going to go now to the denominator. My angle is negative 360 plus theta. I'm going to start at 0. I'm going to go negative 360 and then plus theta. This is negative 360 plus theta. This is in quadrant 1. In quadrant 1, the tangent is positive. Theta is a reference angle because it is in terms of the horizontal axis. Therefore, it will be positive tangent of theta. I won't change the function and I will keep it positive. Next angle is negative 270 minus theta. So Negative 270, I'm going to start at 0. I'm going to go negative 270, and then I'm going to go minus theta. So it's going to be here, negative 270 minus theta. Negative 270 minus theta is in quadrant 1. The sign in quadrant 1 is positive. So this will be plus. It's a positive function. Now theta is a coreference angle because it is in terms of negative 270, and negative 270 happens to be on the vertical axis. Therefore, the sign of the angle negative 270 minus theta will be the same. It will be positive, but it will be the cofunction of theta. And the cofunction of sine is the cosine of theta. And it is positive because they are both in quadrant 1, and the sign in quadrant 1 is positive. Next is the tangent. So of 360 minus theta, I need to know where that is. Where is that angle? 360 minus theta, I'm going to start at 0. I'm going to go positive 360. And then I'm going to go minus theta. So this is positive 360 minus theta. This angle is in quadrant 4. The tangent in quadrant 4 is negative. So it will be minus some function of theta. Now 360 minus theta has theta as a reference angle because the point of reference is 360 degrees. And therefore the function stays as is. So this will be negative tangent of theta. So the tangent of the function of the angle that I have, 360 minus theta, is the same with the tangent of theta, except possibly for the sine. And it is true that in quadrant 4, the tangent will be negative. So when I'm referencing tangent of theta, that is always positive, I have to put a negative sign there. Our last angle is negative 270 minus theta. The angle negative 270 minus theta. I found it before, but let's try this again. I'm going to start at 0. I'm going to go negative 270, and then I'm going to keep going negative theta. So negative 270 minus theta is in quadrant 1. In quadrant 1, the cosine is positive. And because the reference is in terms of negative 270, which is on the vertical axis, the angle negative 270 minus theta shares the same cofunctions with theta. Now, the cofunction of the cosine is the sine. So that will be the sine of theta. And in quadrant 1, the cosine is positive. Therefore, it will be positive sine of theta. So now I really don't need to keep an eye on these positive signs. They were just for me when I was doing the work. I don't need them. I have completed the first step. The first step says, make the angles simple, acute, and positive. So I have expressed everything in terms of theta. The next step says, simplify the fraction. To simplify the fraction, I'm going to cross off any common factors. So I have cosine of theta and cosine of theta. I can cross them off. I have tangent of theta and tangent of theta. I can cross them off. I have a sine of theta and a sine of theta. So the other thing I also have is a negative in the top and a negative in the bottom. And I can also cross those off. So I will end up with sine of theta in the top and tangent of theta in the bottom. The last step says, use fundamental identities to fully simplify to a single ratio. So here, the tangent of theta from the ratio identities is sine theta over cosine theta. And when you divide by a fraction, you multiply by the reciprocal. So this is sine theta times cosine theta over sine theta. And if I write sine theta over 1, then I can actually simplify the sine theta from the numerator and the sine theta from the denominator. And my final answer here will be cosine of theta.